and then a similar type problem, but it may have a little twist to it. It may look different, but our basic knowledge of the overall concept is what's important here. Okay, so I felt like the quiz in AP Classroom has a few of those reach problems, so I wanted to kind of make sure that we're in a good spot. So you learned that your company sending you to Russia, several employees. While we are able to earn equivalent of the current salary converted to Russian currency, a rate of 35 rubles per dollar. Okay, so we need to figure out basically what our new salary is by multiplying by 35. And the easy part about this one is that we have to remember that every summary statistic is affected by it. So by mean, let's be technical about this. My mean is going to be X bar. We're just going to take 605 times 35. Be nice if I had a key ready to go, but I don't, so you're going to have to forgive me while I type this into my calculator. 21,175. Okay. My standard deviation is going to be 250 times 35. $87.50. What else we have here? The median, interquartile range, and range. So here's my median. My median was 750. $26,250. What's after that? Interquartile range and range. So let's do the interquartile range. If I come over here, here is quartile 1 and quartile 3. So we're talking about the difference between these two. So that means I'm going to have an interquartile range of 200. And to finish it off, we have a range. And again, we have a max of 1,000 and a min of 400. So that means that my range is going to be 600. Okay, so while living there, everyone will be given a weekly foreign living allowance of 800 rubles. What does the new mean? So it's my same, except now we're going to add on 800 rubles. Okay, so I hopefully will know that this requires far less calculation because we're going to take that mean of 21,175 and we're going to add 800 to that. So that means I'm going to have 21,975. My median will also move up 800. So it's 21,175 plus 800. Except it's not, I don't know where, my mean and my median are well off. And I wrote down the wrong number. So it's probably easier to grab the eraser and erase all that. So I can grab my pen and write the right median in here. 26,250 plus 800. So we're going to go to 27,050. And here's the part that we have to remember. Each of these three things up here are measures of spread. Measures of spread are unaffected by an addition of $800. Okay? Because my points are still the same exact distance apart. So my standard deviation remains unchanged at 8750. My interquartile range remains the same at 7,000. And my range remains the same at 21,000. Okay, so there we go. As far as that problem, again, understanding what happens when we multiply or divide, add or subtract to a set of data. Okay, wow. I'm going to change it. We have a tire manufacturer believes the tread life of snow tires can be described by a normal model with a mean of 32,000. Just because I get tired of writing zeros, we're going to go with 32K and 2.5K. It'll just help out things immensely. So if I draw a mean in here, that's going to happen at 32K. There's 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below, and we're going to add 2.5. So this is going to be 34.5. This is going to be 36, 37, and this is going to be 39.5. Subtracting, that's going to give me 29.5. That's going to give me 27, and that's going to give me 24.5. And again, this is prepping you for a multiple choice question, so we don't have to be so technical with some of the notation that we need to use. But what tread life would you expect to be the central 68? That's just an empirical rule problem. We hopefully know that that's plus or minus, it's my mean, plus or minus 1 standard deviation. So that means we're going to go from 29.5K to 34.5K. What percent of tires should last over 36,000 miles? Again, if we wrote this out, we want the probability of X being greater than 36,000. So that means that we're going to change that into a z-score, or unless 36 fell on a standard deviation, which it doesn't. So z is equal to 36 minus 32 divided by 2.5. And here again, I'm going to wish I had this ready to go, but I don't, so you're going to have to bear with me. Okay, 1.6 standard deviations. So now we would go to a table and we would look that up. We'll use the table just so we can go ahead and practice using it. I gotta find where that table is. Formula sheet. Okay, this one's still all messed up. Anyway, 1.6 was where we're at. I'm in table B now. Hasn't got too dirty on me. So maybe we'll highlight this one instead. 1.6 lies me at 0.9452. So back to this. I've already forgotten what I said. Was it 0.9452? Man, that's horrible. I better go check that. I'd hate to write a mistake down. 0.9452. All right, I was there. Okay. However, I had to remember that what I failed to do was draw my picture of this. So a tinier picture of it would have been a mean of 32 in the middle. Here's 36 over here, and we're trying to find that shaded region. That shaded region is not. This shaded region is not 94%. So this was a problem where we needed to go 1 minus. So 1 minus 0.9452 is equal to 0.0548. Now, let's be honest with ourselves here a little bit. This is a multiple choice question that you're prepping yourself for. And in no way, shape, or form would I write all this out in a multiple choice type situation. However, I'm going to start giving you partial credit. Instead of being all right or all wrong, I'm going to have you submit your work. So this is where this comes into play. If I'm taking a test, though, if this was the multiple choice part of the test, I'd be doing a normal CDF, a lower boundary of 36, an upper boundary of 1E99, a mean of 36, not 36, 32, and a standard deviation of 2.5. And I am using my calculator and just getting an answer and rolling with it because that's all I need to do. If this was a free response question again, I'd have to use a lower boundary, an upper boundary, a mean, and a standard deviation. Okay? So just remember I have to do all those too. especially is going to happen here on letter D, and I may just jump straight to that. Instead of finding two percentages and subtracting those, I'm just going to cut to the chase. Again, you're prepping yourself for a multiple choice question. So we're going to have a lower boundary of 30, we're going to have an upper boundary of 35, we're going to have a mean of 32, and we're going to have a standard deviation of 2.5. And we're just going to let our calculator do all of this work. If you want to convert that into two different percentages, you go right ahead. I'm not going to stop you. Anyway, so again, I'm sorry. We're going to have to get to all the spots in my calculator. 30, 35, 32, and 2.5. And hopefully I just didn't get in a hurry and mistype something, but we got 6731. Okay. Working backwards, the top 10% of cars last how many miles? Again, what we're going to have to do is, if this were truly a multiple choice problem, I'm going to inverse norm it. I'm going to inverse norm, and we're talking about the top 10%. So that's going to be the top 10%. It may have to be the bottom 90, depending on your calculator. All right, so do know your calculator and how that works with your calculator. And we're going to get, what is that, a mean of 32 and a standard deviation of 2.5. And that's going to give us some value. Let me roll out here and find that. All right, area is 10%, mean of 32 and 2.5, and this is going to be a right tail. So we're going to paste that in there, and we're going to get 35.2. thousand. Okay, miles. This one up here should have been miles too. All right, now, here's the kicker though. The AP exam is trying to get away from you just being able to do this and go with it. So in some cases, it's making a calculation. So what we're going to have to do is we're going to have to inverse norm that 10%. So let's come over here and use my formula sheet. We can do that, and I'm going to move it to the top, the bottom 90%. Okay, so I'm finding a z-score for the bottom 90%. And I'll explain why this is important here in just a second once we find 89%. So I can see from this, here is 8907, here is 8888. So I don't know what I'm doing. I wanted the top 90%, and here I am looking at 88s. This is maybe one of those cases I should stop and redo, but I'm not gonna. So there's what I'm choosing, but from one is 3 10,000ths below, the other one's 15 above, so we're gonna choose this one. So again, we're going backwards. If I could grab my tool, and I'm gonna go this way with my red line, that's a 1.2, and we're gonna follow this up to an 8. So I know my z-score is 1.28, and I'll explain why this is critical right now. So if we were to convert this into, we said 1.28 would be my z-score, x minus 32 divided by 2.5. And here's why our ability to do this is important, because then the math to do this would be 1.28 times 2.5 plus 32. And what's going to happen is it's going to be a multiple choice question, and this is going to be your response. So you are stuck with having to then do all 5 of these calculations, because you're going to have choices A through A, B, C, D, A through E, E. Okay, so you'd actually have to mathematically calculate all those to see if it matched up with this, or you're going to have to realize that they're doing it from a z-score, and I have to be able to do this right here if I'm going to get to the answer faster. Okay, so that is definitely something we have to watch out for. I wanted to really point you at that, because that may, if you can see me, I'm winking right now, may happen on your quiz. All right, 2 of the 7 events for the Olympic heptathletes are the 200-meter run and the javelin throw. The average 200-meter time is 23.2 So the mean of the 200 so it has a mean of 23.2 and a standard deviation of 0.3. And we have the javelin, which has a mean of 50 meters and a standard deviation of 3. Okay, now earlier last week I was helping somebody try to understand, well, what is a large and small standard deviation? Here we have a 0.3 and here we have a 3. A lot of it's depending upon your scale and how far apart my min and my max are. Here we're talking about 200 times. And 200 times, they're going to come in pretty close. I mean, pretty close to each other. Granted, if you lost by a second, okay. Again, your difference between your first place and last place may be going to be 3 to 5 seconds. Okay. However, you come over here to the javelin throw, and the difference between first and last place may end up being like in this case, 18 meters. If you remember, a curve is like 6 standard deviations across. All right. So if you took 6 times 3, that would be a distance of 18 meters across your curve. If you did over here, this is going to be a distance of 1.8 seconds across your curve. So again, it's all dependent upon scale. Okay, so that's what it has the impact on my standard deviation. Anyway, that is not what this question asks. Which we have Gertrude, who won the 200 meter with a time of 22.5, and we have Ingrid, who won the javelin with a distance of 56.1. Which performance was better compared to the athletes? And again, we have 2 different scales that we're operating from, so that forces me into converting for a z-score. Okay. So we need a z-score for Gertrude running the 200 meter. She ran it in 22.5 seconds. We expected Gertrude to run it in 23.2 seconds. And we had a standard deviation of 0.3. So again, we have to take the time for me to type this into my calculator. 22.5 minus 23.2 is negative 0.7 divided by 0.3. So negative 0.7 divided by 0.3 gives me a z-score of negative 2.33. So we can say she was very, very fast compared to her other runners. Okay? So now we also need a z-score for Ingrid, who threw the javelin. She threw the javelin 56.1 meters. But we expected her to throw it 50 meters. And we have a standard deviation of 3. So that means that we have 6.1 divided by 3. So whatever that turns out to be, it's not going to be... All right, so 6.1 divided by 3 is 2.03. And this is where, a little bit of perspective matters. It's pretty easy to say that... because the faster we are, the better we are. Gosh, if I could talk right. So the faster we are, the better we are. So the further below the mean we are, the faster we were. Whereas on a javelin throw, we want to be above the mean. So the further I am above the mean, the better off I am. So in this case, though, we're going to claim Gertrude as the winner. Was more standard deviations below the mean at negative 2.33 than Ingrid was above the mean, because she wanted to be above, Gertrude wanted to be below, and so and actually, in reality, we could just say Gertrude is more standard deviations away from the mean, okay? Was above the mean at 2.03. But again, that's why we use these scores, standardized scores, so that we can compare 2 things on 2 different axes, okay? A machine that fills antifreeze jugs with antifreeze fills according to a normal model. It has a minimum of 127.2 and a maximum fluid ounce and a maximum of 130.8 fluid ounces. Give an appropriate mean and standard deviation for the distribution. So Here's what it's telling me. It's going to be a normal curve. We've got 127.2 down here at the minimum, and we've got 130.8 up here at the maximum, and it wants me to give an appropriate mean and a standard deviation. Okay, and so a mean is going to be, and again, this is one of those extension problems. We haven't done anything like this. Okay, but we should have the skills to do it because we know the mean is going to happen right in the middle. So I need a mean. I'm going to find an average of 127.2 and 130.8. And we're going to find an average of that, and that will tell me what an appropriate mean would be. $129 fluid ounces. Standard deviation. What I have to remember is that in a standard normal curve, there are 1, 2, 3 standard deviations below, 1, 2, 3 standard deviations above. So there are 6 standard deviations equally split across here. So that means that we can find the difference. 130.8 minus 127.2 is the distance across, and then we're going to divide that by 6 because I have 6 equal increments to divide that into. So that's 0.6 fluid ounces. All right, and our last one here. Manufacturer claims that the lifespans for their copy machines in months can be described by a normal model with a mean of 42 and a standard deviation of 7. The last E-Hall copier had a Z-score of negative 1.25. Interpret that score and what percentage of copiers lasted that long. Okay, so again, we have interpretation of that Z-score. Okay. So the E-Hall copier lasted 1.25 standard deviations below the mean lifespan. Okay. Now we have to, and again, this is that extension part as far as we are, the ones in our homework probably prepped this with, we had a percent to go back to a value of X. This does not, it has a Z-score, but, so negative 1.25 is my Z-score. The observed value is what I'm trying to find. I'm expecting it to last 42 months, and it had a standard deviation of 7. So again, this is a case of, we can't use our calculator to, we could, if we want to find out the percentile that is left of negative 1.25, we can find that in a table, and then we can use our calculator with an inverse norm and go backwards. But you know what, it's just as simple to hopefully understand the mechanics of what we're doing, and we can solve that. So I'm going to multiply the 7 over. And then we're going to add the 42 on top of that. And we're going to get 33.25 months as my answer. All right, so again, some of those might have had a little different, and the whole point of this was, sometimes it's knowing them, being able to extend what we did onto all cases. It may look a little different, but we just have to be able to do that. All right, so I'm going to shut this down.